Hello everyone, my name is Mohit and I welcome you all to my YouTube channel. I'm going to start a new playlist on solving DSA challenges in Python. And in this data structure and algorithm challenges playlist, this is challenge number one, where we need to find middle node of singly linked list. Okay, so let us understand this problem statement. Okay, so since this is first video of this playlist, so for those who don't have much idea about linked list, I'll give a very basic information so that from this video and from the next video onwards, we can directly start writing code based on the problem statement. Okay. So I'll just take few minutes in order to give a very basic overview what is required to understand linked list. Okay. So here you can see we have two nodes and first node has value 1, second node has value 2. And we can see a pointer called next in every node, right? So from here we can conclude that a node will have two property or two attribute. One is its value and second one is this pointer called next. When this next pointer will point to this node 2, this 1 and node 2 will be connected. Okay, so just have this very basic understanding and you will get much better picture of it when we start solving problem. Okay, now according to this problem we have to find the middle node, right? So let's say this is the singly linked list given. Why it is singly linked list? Because it is propagating in a single direction. Okay, so from 1 to 2, then 2 to 3. You cannot come from 3 to 2 because it is not pointing in back direction. It is only pointing in single direction. Okay, so it is named as singly linked list. So in linked list, you will see couple of more attributes like this pointer pointing to the first node, which is called as head, and this pointer is pointing to the last node, which is called as tail. Okay, so in a linked list, head will point to the first node, and tail is basically a pointer which will point to last node. And in this example, we have total three nodes. So of course, middle node will be this one, the node with value 2. So according to this problem statement, we have to find this middle node. Okay. And let's say if we have even number of node, then you need to return first node of second half of that linked list. Okay. So let's say if you have 1, 2, 3, and 4. So in that case, second half will consist of node with value 3 and 4. And first node of this second half is node 3. So we have to return this particular node with value 3 in case of even number of nodes. Okay, so I hope requirement is clear. Now let me switch to Visual Studio Code in order to solve this problem. Okay, so again, since this is the first video, so I'll go and create node class and linked list class from scratch. But from second video onwards, we can use these class what we are creating now. Okay. So as we already know that linked list consists of multiple nodes and each node will have value and next as its attribute. So first we will do what? We will create a node class. So I'll write class node and this will accept value of node. Okay. So we will initialize this value as the value which we are providing in this parameter. And we also know that we have second attribute of a node which is next, right? So this pointer next is an attribute of a node. So for an individual node, this next pointer will point to nothing. So we will keep this as none. Okay. So this we have created node class. Now next we will create linked list class which will use already created node with value and next property plus it will also initialize these two attributes which is head and tail. Okay. So we will name this class as singly linked list, okay, and inside which we will define and pass value of node, right? So basically when we are trying to create linked list, we are passing a value with which node should be created. So let's say we are passing value as 1. So a node should be created with value 1. In that case, we can use this class in order to create node, right? So we can use new node equals, we can call this class and we can pass this value. So it will create node with value 1, which will look similar to this first node, right? And we also want to create head and tail pointer. And since there is only one node, so both will point to this newly created node, right? So head will point to this new node and tail will also point to this new node. Okay. Now there is one extra attribute. When you create linked list, you also need to maintain length of this list. Okay. So first time when you create a linked list with single node with node value as 1 and head and tail would point to this node, this single node, right? Because there is only one node in linked list. And then when we add 2 with 1, then there are two nodes in this linked list, right? So head will point to 1 and tail will point to 2 and the length of list become 2, right? So we need to maintain length also. So in this case, it is 1 while initializing, right? So we have created node class and a singly linked list class. Now let's see one thing. Are we able to create single node or not? We will use singly linked list inside which we will pass value as, let's say, 1, and we will name this instance as LL. Okay, so we have created an instance and now we want to check what is the value of head, what is the value of tail, and what is the length. So we will use head value is LL dot. So inside this instance, we have head attribute and head is nothing but pointing to this node and this node has a parameter called value. So in order to check the value of node which this head is pointing to, we can use dot value, right? Similarly, we can see tail pointer is pointing to which node, and then we can see what is the length of this linked list, right? So here instead of head, we'll pass tail and ll dot length because inside this instance we have an attribute called length. So if we run this, see head value is 1, tail value is 1 and length is 1. That means head and tail are pointing to same node and the length of linked list is 1. Now in order to solve this problem, let us create a linked list with these three values. So for that we need to create a method called append, and since this is also inside this class, so we will mention self and then we'll pass value. Value means what should the value of node we want to append. So first, using this value, let's say we are passing this value as 2. So basically we want to create a node with value 2. So we can use this class called node in order to create a new node with value 2. Now node is created and then we will check if linked list is empty or not. So let's say if linked list is empty, then this new node will become first node, right? So if it has become first node, we will write self dot head equals new node. Head will point to this new node and tail will also point to this new node, right? And if length is not equal to 0 for this linked list, then what we will do? So let's say if linked list already have this one node. So in that case, what we will do? this next pointer, which is pointing to none, it will point to this newly created node. Okay, so you can see it here. This self dot head, which is pointing to this node, dot next, which is equal to new node. But while we append new node to linked list, we will add this node in the end, right? Actually, I'm missing one. There should be next here also for node number 3. I missed it. So sorry for that. So what I will do, self dot tail, which is pointing to this last node, dot next. So basically, next was pointing to none. So what we'll do, self dot tail dot next equals new node. Okay. So self dot tail, which was pointing to last node, and we have next attribute which was pointing to none. Now it will point to new node, and then we will move this tail pointer to this last node because now it has become last node, right? Self dot tail equals new node. So now tail will point to this new node. Okay. Now only one thing remaining, that is we need to increment length attribute by 1 since we are adding a new node. Okay. So by using this method, we can add a new node at the end of the linked list. Okay. Now let me add one more method called print value. This method will basically print the value of nodes in a linked list. Okay. So we will use a temp variable with self.head. So basically temp variable will point to first node, and we will check every node. So while temp is none, we will do what? We want to print value of node, right? So in this case, temp is a pointer to every node, and node has an attribute called value. We can print it, and once done, we will move this temp pointer to next node, right? Okay. So this particular method will print the value of node present in a linked list. So here what we have done, we first pointed this temp variable to this first node, which is self.head. Then we printed its value, and then we move this pointer to second node by using temp equals temp dot next, right? So this become temp. Then again we printed the value of the second node, and we moved this pointer from node 2 to node 3 by using temp dot next. So basically we are taking the use of this arrow or the attribute of a node for traversing to next node. Okay, so now our base code is ready, and we have created node class. We have created singly linked list class, inside which we have created multiple methods starting from print value in order to print value of every node inside linked list, and append method in order to add a new node in the end of linked list. Okay, so now what we will do, let's say we want to add node with value 2, and let me comment this, and let me call this method print value. Okay, so let me save it, and what I will do, I will initialize this linked list class with value 1, so it will create first node, and then I will append the second node with value 2, and then I'll try to print value of these two nodes. So let's see. I will save this file. I will run it. Okay, it has not printed anything. Oh, there's one mistake here. Actually, this should not be none. While temp is not none because we are checking on every node, right? And a node cannot be none, right? So as soon as node will become none, that means we have reached to the end of this linked list, and we want to exit this loop. So this we have to add, like temp should not be none. Now let me save this file. Let me run it. See, it has printed first node, second node, that too in order. Now let's say if I want to append one more node. Let me run it. See, it has printed three value 1, 2, and 3. Okay. So this is the basic code which we will be using very frequently in our next videos as per the requirement. And there I will not explain these things in that much detail. So you can refer this first video whenever required. Okay. Now coming to our original problem, which is we need to find this middle node once linked list is created. So we have created our linked list. Now we need to find this middle node. So in this case it is 2, right? So what we will do, we'll define another method called middle node, and since this is inside this linked list class, we'll put self keyword. So in order to find middle node, we first need to know what is the position of that middle node, right? So what we will do, we will create a variable called counter, and we already have information about length. So in this case, length of linked list is 3, right? So in this case, the middle node is this second node. So in order to find this middle node, we only have to move one step, right? So in that case, what we will do, we will define this counter as self.length divided by 2, and this will be an integral value. It will output the immediate previous integer. So in this case, immediate previous integer is 1. So counter is 1. So we will run a while loop till counter becomes 0. And inside this while loop, we'll do what? First, let me create a variable, a temp variable to first node. So first node has always head pointer. So we can assign this variable with self.head. And now the counter value in this case is 1. So we will go inside this while loop and we will move this pointer to its next node. Okay. And then we will decrease the counter by 1. So in our case, counter was 1. So it will come inside this while loop. And temp variable was pointing to first node. Counter is 1, which is not equal to 0. So it will come inside this loop. This pointer will move to second node. It will reduce counter by value 1. It will become 0. So it will come out of this loop. And we have this temp pointer pointing to second node, which is our middle node, right? So we will just print this node value. Okay. And this is the requirement. Now what we will do, we will comment out this line. Let's save this file and run it. See, answer is 2. And now let's say if we are adding one more node in order to check if it is working for even number of node or not. Let me add more new node with value 4. And before running this command, let me check whether it has successfully added or not. Okay. So we have 4 node, 1, 2, 3, and 4. Now we will try to print its middle value. Sorry, let me save this file first. Now run it. See, middle value is 3, which is first node of second part of linked list or first node of second half of linked list. Okay. So this video was a bit long because I explained some required method that we are going to use in this and upcoming videos. So if you have understood these things, it would be really helpful from the next video onwards, as we are not going to discuss in this great detail for reusable code. Okay.